Uh, I'm Suan Jung from PhD team. And today's my talk is about ZK development tools. So it is kind of introducing several frameworks and just not going deeply for the technically. So first, I will introduce some tools for writing circuit with existing libraries like Circom, Halo2, or ZKVM. And next, I will explain about circuit safety and tools for it with formal methods and static analysis. And lastly, it is very rarely used techniques for the frameworks, but it is writing own modular system with Acros or modular libraries. So let's start with ZK circuit development. So when people are starting to code their circuit, then they would wonder that how to write a circuit. Before they get the answer, then they will get another question that is, so what is circuit? So I think the circuit is the procedural computation, theoretically. So it consists of gates, which are addition or multiplication. And it is also directed cyclic graph, so it gets input from outside, and then it will calculate the output with topological order. So it's GKP from circuit. So all GKPs are from proving schemes, and they will define what to prove inside of the protocol. So all proving schemes just have kind of constraint system inside of it. So it is not the circuit, what I mentioned before. So it's kind of the relation of polynomials. So in RNCS, it is matrix multiplication. So it's a series of polynomials. And also in Plonkish arithmetization, it is also a series of polynomials. So this gap between the theoretical circuit and the circuit development can confuse what is the ZK circuit development. So we call it circuit, but actually it consists of the relations of conditions and rules of allocating values to these conditions. So it is why ZK DSLs have two parts, which are constraint generation and witness generation. So you should be aware of this fact that circuit is not the program, but it is a set of constraints and rules of allocation to these relations. So let's see with real world examples. So Circom is our most famous ZK DSLs for now. So it has constraint generation with these three equal signs in the code. And witness generation part is other parts except constraints. So Snark.js does witness generation with this with other part of WASM or generating from the Circom compiler. So it's a very low level framework. So there is no overhead for making constraints. So I think it is hard to understand workflow at first because all parts are integrated to the same code, but it is actually very different for the workflow. And Halo 2 is very famous for used by ZK EVM, and it is also very complicated. So you can understand constraint as relations that is defined before values come inside. And the constraint generation part is up to the abstraction, but you can think it is a configuration for some kind of relations of values. And witness generation is for assigning values to the circuit. So it is also very low level and can be hard to understand because all logics are hidden in the Rust code. So there are many approaches to reduce this hardness of understanding for this circuit. So one of the approaches is Halo to Wrong made by PSC team. So it is a kind of abstraction layer for general use. So it has three layers for this insight. So main gate is the base layer for the library. So it has all arithmetic operations, predefined arithmetic operation inside. So you can just bring it to your code and just integrate to your code base. And ECC and non-native arithmetic field arithmetic is built on that. So it can be used to many cryptographic primitives as well. So you don't need to define any gates with this hello to wrong library. And there is very different approach for eliminating constraint generation and witness generation, which is GKVM. So GKVM is kind of making circuit, but all things are predefined before your code. So GKVM proves the execution of VM. So if you write a program, then compiler will generate the VM's execution trace, and then the prover proves the execution trace of VM. So let's see how it reduces the constraint generation and witness generation. So circuits are predefined for each instructions of VM, and your code will be one of instructions for the VM. So for example, like add instruction. So if you write the addition in your code, then it will compile to add instruction. And also constraints are already defined in the VM, so you don't need to write the constraint generation logic or witness generation logic for the GKVM. But however, it can make an overhead for sure, because if you write an assembly program, then it is very optimized. But if you write the C or ROS program, that it will generate the bunch of codes for the same logic. So next, we will see tools for circuit safety. So the circuit safety is very important for the ZKP because it is utilized to uphold user privacy or like verifying computational integrity. So let's review this epistemic gap of circuit development. So you can see that theoretical circuit and circuit written in DSL are very different. I mean, for your information, is really different, but I mean, yeah, for abstraction. So the theoretical circuit is a procedural computation by topological order, but in the circuit written in DSL is kind of arithmetic relations between the values. So this gap can make vulnerabilities to your circuit. And also, the ZK circuit is very different from the program. This ordinary program is Python for checking whether x is 0. So it returns 1 if x is 0, and else then returns 0. But in this GKP circuit, it also behaves same, but you should make more constraints because y is not initialized. So it can be any field element, so you should make constraints for that. So there are several common vulnerabilities for GK circuit, and you can check it in this GitHub repository by Xerox PARC. So in my opinion, I think under constraint circuit is most dangerous bug for circuit. So under constraint circuit is the circuit that doesn't have all of the required constraints for the circuit. So multiple output can satisfy the same constraint for the same input. So let's example. This is a decoder circuit that decodes input to the output. So if the W is the length for the decoding value, and if the input is bigger than length, then it will fail and the success value will be 0. So when you put 2 to W and 1 to input, then you can get out 0 should be 0 and out 1 should be 1, and success should be 1 for a valid case. But this invalid input just satisfies this circuit because this assignment is not constrained. It's just assignment, so it is not affect to the circuit constraint. So to prevent this error, there are several tools for check this under constraint problem. So there is circumspect, which is static analyzer, linter for circum, which is made by Trail of Bits. And this is a command line interface tool. So it can get the warning from on assignment or like on constraint. And next tool named Picus is made by Veridice, and it checks the uniqueness property of the values. So it uses static analysis and SMT solver, and it is announced with this paper. And it will make counterexample, which I mentioned before. Just they have several possible outputs for same input, so it can be bug for the circuit. And next tool is named Correct, and this is for checking correctness of Halo 2 circuit, and it is made by QuantStamp, and as known as Halo 2 Analyzer. So it is checking unused gate and unconstrained cell and unused column with the Halo 2 code. So for most tools are for Circom or RNCS, but if you are new to ZK, I recommend using Circom for safety. However, many static methods and formal methods are made, so I think really we need more safety tools for ZK circuit for Halo 2 or the Plonkish arithmetization. And so for now, just ZK circuits need to get audited before the production. And next, if you really want to make an extremely optimized thing, then you can design modular structure for your work. Before using this technique, you should be aware that it can be very dangerous for your security, because all modular structure is audited for each, but it doesn't guarantee that the whole integrated structure is also safe. And also it can be over engineering for your work, and I think it is not for simple circuit, but for complex protocol like IBC or recursive snark, folding schemes, ZKVM. So workflow is like this. You should select cryptographic protocol to use, and you should find out which requirements are in the protocol, like which field or elliptic curves should be used, or which arithmetization is used. And if it is interactive protocol, then you should use Piaget transformation. And after that, you can build with existing libraries that implements this kind of requirements. So I recommend using Rust because many tools are written in Rust for these cryptographic primitives. Yeah, from finite field and elliptic curve, I think many works are using ArcWorks, finite field implementation, or ZK Cryptos. So if you choose using existing library for the proving schemes or other components, then you can like align the same finite field implementation with it. So if you need use, and also if you need use like certain elliptic curve, then you should find any kind of implementation for elliptic curve. For example, BN curve in Halo 2 curves. And for arithmetization, if you choose RNCS to use, then you can use RNCS binary format made by IDEM3, which is formalization of RNCS format. And then you can use also parser in Rust made by Zero Pool Network. And for Plonkish, you can use front end for the Halo 2, which is made by Zcash. And with the Plonkish arithmetization, you can use Hans implementation for proving system using Plonkish. It is modular system, so its front end is Zcaches. And also you can replace the polynomial commitment scheme in this modular structure. So it is very easy to replace some components in the library. So you can do benchmark, or if you implement something on the top of that, then you can just replace and do testing. So very easy to use. And also for the interactive protocol, then you should use Wiershammer transformation for sure. So recently, Nimue was made by Arcworks. It is performing Wiershammer transform for public coin protocol, so you can make your own like public coin protocol for this protocol. And you can make your own using well-known hash like Memc or Poseidon. And addition of that, just you can make a ZK VM with this Powder toolkit. It helps build ZK VMs and similar proof frameworks. So you can set any VM front end for this framework. So you can put the RISC-V or any other ZK VM that defined by yourselves. And you can use backend Hello 2 or eStar. So it will generate witness automatically. Yeah, thank you for listening.
So now we have 5 minutes Q&A time. Does anybody have questions? Okay.
So in developing your own protocol, can you combine the Plonkish repo with the like the artworks like tooling stuff?
Yeah, you can just if you want to integrate something on the top of that, just you can align some like encoding for like field element or something. Then you can use it with any things with the modular system.
So the API itself is compatible. The API itself is it compatible?
Yeah, I think it's compatible with the Arcworks or something else.
Okay. Is there any like toy example repo that I can reference on? Is there any repo that is based on this kind of design? Like for example, you use like Plonkish, and then it also combined with the Artworks tooling.
Yeah. So did you ask about some other implementation that uses Plonkish?
No. I'm asking like if there are any like example repository that use the similar techniques, which is using Hans Plonkish repo and then integrate with Artworks.
Ah, I cannot remember the exact name, but yeah, I will talk about later.
Okay. Thank you.
Okay.
Do you have an example repository that takes your modular approach?
Yeah, it's Hail to Lasso, which is made by Do-Hoon Kim. So it uses the Lasso for the lookup argument system for the Plonkish arithmetization and yeah, doing some
Can you repeat
modular.
the name again?
Halo 2 Lasso. It's a kind of like for dev tool, but yeah, you can use it for.
What's a mature open source ZK VM?
ZK.
What's the most mature open source ZK VM in your?
For ZK VM, I think like ZK VM, the ZK DSLs using ZK VM is kind of like Noir or Alio or Cairo is just using ZK VM for in the inside of the design of ZK DSL.
Does anybody have more questions? Okay. Thank you so much, Suwon.